Hello, good morning, good afternoon, good evening, depending on where you are watching me from. Matt is here again. In this video, we are going to linearize non-linear systems uh, in a given region. Yeah, it's simple as ABC control theory. Those of you who are in engineering, yeah, you might be hearing control theory and somehow finding it difficult. I'm going to break it down for you. Is that clear? Yeah. Before we begin to solve any problem here, let's just pray to our God for retentive memory and more understanding. For 2 seconds, we are in prayers. Amen. Yeah, I love you guys. Please, if you have any mathematical problem or challenge, just snap and send it. Is that clear? Share with me. I'm going to solve it and make a video like this for you, so that it is not easy for one to follow someone. Yeah. So that is what I can do for you. It's okay. If today is your first time of meeting me here, go to Google, type Math, amen. You will see a lot of solved mathematical problems with solutions. Not only that, you also see comprehensive mathematics lecture notes for those of you who are preparing for NECO, WAEC, GC, NC, JAM, ND, HND, BSc, Masters up to PhD level. It will do you good. You can also meet me on Facebook. The Facebook own is this form. Type Maths. Yeah. Facebook. Then type this on Twitter, TikTok. You also meet me there. Then YouTube. Type this. You will see me there. Please don't just watch the videos. Try and subscribe to my YouTube channel and follow me on Facebook. Facebook, I do come live, yeah. So I will learn this mathematics together. Is that clear? So please don't just watch, help me share. Thank you and God bless you. Okay, yeah. I want to look at this problem. They said we should linearize this system. But before we linearize this system, I want us to know something. What when is a system said to be linear? Let's look at it. Let us have a straight line, mx plus c. This is a straight line, isn't it? This is constant, true or false? So we can assume this to be what? Linear. This is a linear system. But when we have, by the time we have z equals to assuming 2x plus y, this is not a linear system. Take note. Is that clear? Why? Because we have two functions. We have x and y. So it can never be a linear system. Even if you have functions of this form, it can never be a linear. This is non-linear. Is that clear? Except we have a system of this form, we can say this is a linear system. Yeah. So please take note. So let's look at this system. I'm going to teach you how to linearize non-linear system. Is that clear? So we write solution. Amen. Let's write solution. The system is given as z equals to 2x squared plus 4xy plus 5y squared. Yeah, the formula for linearizing system is we have our z, amen. Z is equals to K1 all over open bracket minus x bar plus K2 open bracket, since it has to do with x and y minus y bar. Is that clear? Okay. So what we need to do here, where our K1 is equals to partial z all over partial x, amen, at x equals to x bar, comma y equals to y bar. Okay, then K2 is equals to partial, since it is not a non-linear system, partial z all over partial what? Y. But supposing it's linear system, definitely we are supposed to have x1, x2. Please take note, yeah. But since it is non-linear, we have x and y in the system. At, amen, at x equals to x bar, comma y equals to y bar. Take note of this. These things are very necessary, yeah, that will help us. Okay, so now what we need to do here is we are going to find the mean of x in this region and y in the region. So first, finding the mean for x, amen, mean for x, that is 9 less than x equals to x less than equals to 11. So our x bar is going to give us what? 9 plus 11 all over 2, which is, since the mean you divide it by 2, so 20 all over 2, which is equals to what? 10. So this implies that our x bar is equals to 10. Please take note. So our y bar at y, mean for y is 3 less than equals to y less than equals to 5. So our y bar is equals to 3 plus 5 all over 2, which is equals to 8, amen. 8 all over 2 equals to 4. So therefore, our y bar is equals to 4. Do you agree with me? Okay, so now what we need to do here is, yeah, we are going to differentiate. If we want to obtain our K1, let's obtain our K1. We'll differentiate this function partially with respect to x, true or false. So if we differentiate z equals to 2x squared plus 4xy plus 5y squared. If we differentiate to obtain k, that is to obtain k1, we differentiate this partially with respect to x. It means our partial z all over partial x is equals to, if we differentiate 2x squared, since with respect to x we will have 4x, amen, plus if we differentiate 4xy, we will have 4y. Then here is 0, true or false. Then it implies that our k1 is equals to partial z all over partial what? X. So k1 will now be x, 4x plus 4y, true or false. Okay, so do you agree with me? Yeah. 4x plus 4y. Yeah. So far so good. So from here, our x Note that our x here, our x is equals to x bar, which is our x bar is 10. True or false? From here, look at it. So take note. So if we want to obtain K1, our K1 will now be equals to 4. Our x is 10. Then, likewise, our y is equals to y bar, which is our y bar is equals to what? 4, isn't it? 4 plus 4, open bracket, what? 4, isn't it? That is K. Yeah. So here we are going to have 4 times 10, 40, 4 times 4, 16. So our K1 will now be equals to 56. Take notes. Yes, likewise, to obtain K2, we differentiate this function with respect to y, partially. So our partial z all over partial y will now be equals to, if we differentiate this idiot, here will be 0. Then if we differentiate 4xy, we are going to have 4x, then plus differentiate 5y squared, we are going to have 10y. So for us to obtain K2, K2 will now be equals to, since partial z all over partial y is our K2, look at it here. So here will now be 4x plus 10y. Then our K2 will now be equals to, amen, will now be equals to our x is what? 10 plus 10 times y is 4, isn't it? 4, amen. So this is equals to 40 plus 40, which is equals to 80, isn't it? So our K2 is equals to, amen, K2 is what? 880, sorry. So now, at this point, they said we should linearize the nonlinear system. This is it. So what we need to do is we transform this here, we transform this one here, that is okay, sorry, before we do that, we can do that, but before we do that, let's obtain our z first. Is that clear? Okay, let's do that first. We transform it. Our z bar is equals to 2. We turn this to x bar square plus 4x bar y bar plus 5y bar square. Amen. So our z bar will now be equals to, amen, our z bar will now be equals to, what is our x bar? Our x bar is 10, isn't it? So 2 open bracket 10, since x bar is square plus 4 x bar is 10, amen. Then y bar is 4, then plus 5 y bar is 4, but y bar here is square, all is square, amen. So if you can see what I am saying, this will going to give us 200, isn't it? Because here is going to be what? 100, 10 times 10, 100. So 100 times 10, 200, plus here we're going to give us 40, then 40 times is 160. 40 times 4, 160. True or false? Then plus here will give us 16. 16 times 5, 30 carry is 80. True or false? Okay, plus 80, right? So let us add this. 200 is 444. I think so. 200 plus 160, 80, 0, 14 carry 4, then carry 1 to 2, 3 plus 1, 4, 440. Amen. Okay. So here is going to be 4. Sorry, our Z bar is going to give us what? 440. Okay. So now at this point, can I clean this up? So at this point, if you can see what I am saying, let's recall this. Is that clear? If we recall this, this implies that if we recall this, this implies that I think here is supposed to be Z bar. This is Z bar. So we now show our Z minus Z bar is equals to K1 open bracket X minus X bar plus K2 open bracket Y minus Y bar. Yeah, this is how it's supposed to be, the formula. Okay, this one. So what we need to do here is, can I clean this part? Let me clean here. Amen. We clean here. So at this point, what we need to do here is for us to substitute in the parameters. Is that clear? That is the values. Our Z minus Z bar is 440 equals to our K1 is 56. Then our X is what? Our X is unknown because they did not give us X. Our X is unknown, so we leave X. Our X bar is 10, then plus K2 is 80, amen. Then open bracket Y1, Y is known, then Y bar is 4. So what we need to do here is for us to multiply out this 10 times 56 is 1,560, right? 56 0 0 6 6 5. True or false? 5,600. Sorry. So 5,600. Okay. 56 times 56x minus 5,600, then plus 80y, then minus 320, right? 320. Okay. Yeah. So what we need to do here is for us to want to obtain this, is for us to obtain Z. Our Z will now be equals to, our Z will now be equals to 5 6x plus 8y, then minus 5,600 minus 320. This one crosses the sign of quality, becomes plus 440. Yeah. Oh, sorry. 5 6 times. This is 560. 560. I think so. Yeah. This is 560. This 0, right? 0 6 5. Sorry. 560. Sorry. I was very fast. So 560. Let's add up. Let's add up 560 320,088, isn't it? Yeah. So let's print this part, amen. So here would be z is equals to 56x plus 8y, then minus 8880 plus 440. So it means our z is equals to 56x plus 8y. So it's going to give us minus 440. So we are trying to linearize the system, this system. Look at it. So this is how you are going to break it down. So should in case you have any question, please drop it on the comment section. Make sure you share this video. Is that clear? See you in the next video. Bye. Love you guys.